For this video, we're going to continue with the next step in the lab, which is going to be to add in the ghosts and add some movement to the ghosts so that they chase our Pac-Man player around. For the purposes of this video, we're only going to do 2 of them, which is the minimum requirement for your labs, and the 2 will behave slightly differently from each other. And this should give you a good framework to, if you have time, extend it and build in 2 more ghosts with your own methods of movement. So just as a quick reminder of where we are in this lab, if I run my game here, you can see I've got my board that appears and I have my Pac-Man and I have controls. I can move it around the board. That all looks pretty good. One thing you're going to run into pretty quickly is that we know our ghosts are going to need to be children of our character here. So they're going to have a target tile. That's the tile they're targeting. Well, at the beginning of the game, there aren't any tiles that exist, so we can't pre-assign them a tile. The tile needs to be assigned when the game starts running. There are a lot of ways you could do this. You could give a tag to one of your tiles so that an already existing ghost model could move to it at the very beginning. But the way I'm going to do it is I'm actually going to make a new tile type that functions similar to my player tile. So it's up to you if you want to do this the same way that I do. It'll involve a little bit of editing of the scripts that I've already written for you, but I'm going to walk you through how to do that if you decide to do it this way. Let's look at that start tile. So remember from the structure of the project that our start tile here has our Pac-Man model built into it, and that player has this tile assigned. So because they both exist in the same prefab, when I start the game, it already has that tile assigned. We can do the exact same thing with the ghosts, but we need to make a new tile. An easy way to start out is I'm actually just going to duplicate this prefab. You can do that by either going to Edit, Duplicate, or using the same shortcut you would use for a game object in your scene, which on Windows, which I'm currently on, is Control D. If you're on Mac, it is going to be Command D. And let's rename this. So this is going to be my ghost tile. Coming into my ghost tile, we can get rid of the player here, and I'm going to replace it with a ghost. So goodbye to Pac-Man. And I'm going to add one empty layer that I'm going to name after my ghost. In this case, the first one I'm going to implement is Blinky. And underneath Blinky, actually, let's first make sure that Blinky is right at the origin of our model. And underneath Blinky, I'm just going to use a very simple basic shape. We'll use a cube, shrink that maybe a little bit, and move it up. Actually, I think let's check on the player tile. I moved the sphere up by 1 meter, so I might as well do the same thing for our ghost. There's our cube. Let's move it up by 1 meter. And we probably want to give it a color too. So Blinky is the red ghost in Pac-Man. So I'll make a new material, create material, name it Blinky. Because I'm just giving these basic colors, I'm going to change the shader to unlit color, which is the same thing I did for Pac-Man. And we'll make it red because this is the red ghost. And there we go. So we now have a tile that has one ghost pre-created and existing on it. I don't have the script written for the ghost movement yet, so we'll get back to this in a little bit. But the other thing we want to check is that on our tile here, it's got the tile script applied, good, and it's an open tile, which is good. We want this to be a valid tile for both the player and the ghost to move across. Now for the slightly tricky part, which is I need to make a few updates to my code to include this new tile in the level generation. And let's start out by looking at on our level manager here, the level manager script has a list of all of the prefabs of the tiles that we need. So that's a good entry point to know we need to add another one of those. So here's our level manager script, and there are those prefabs that we're populating in the editor. So I've just added one more. And just kind of following through the logic of what's happening with the other tiles, you can see that at the start here, I am assigning them to these variables in level. So let's go there next, actually. So level also has these prefabs. It's not necessarily the cleanest way to do it, passing these to a static variable, but for the purposes of the lab, it's an easy and clear way to give you access to it. So it has these static variables, and if you recall, static means that it belongs to the class, not to an instance. So any instances of a level that you create will all share the same prefab. Doesn't matter too much, but let's just add one more for our ghost prefab. And then back over in Level Manager, now that that exists, I can assign it. So the level class has a ghost prefab static variable. And I can assign to that the same prefab that I am dropping in here. Back over in the editor, this has now appeared. It's empty. So let's grab our new prefab and drop it into there. So now the level manager should be prepped and know what tile it needs to spawn when it's looking to spawn a ghost tile. How do we get it to actually do that? If you remember this level script over here, it's got this character-based description of the level. We need to add another one to that. So up here, I'm going to put a comment before I actually go ahead and do this. And I'm going to say I'm going to use the G character to indicate where the ghosts spawn. Which will be the spawn tile for the ghosts. That's happening up in level. So if you go back to the level script and you scroll down a little bit, there's this create tile that's happening. And in create tile, it checks which character is being used currently, and it gets the right prefab and instantiates it based on that. So we just need to add one more case here, which is if it's a G, we instantiate our ghost prefab at the position this tile is supposed to spawn at, which is being passed in right here. And the rotation can just be the prefab's rotation. It doesn't really matter. Well, it doesn't matter as long as it's not rotated in some horizontal orientation. Not horizontal, diagonal. Great, so now we got that. That's all coming from up here. Doesn't really matter too much. That should cover everything we need, unless I've forgotten something, which I probably have. If we go back over though and I try to run it, let's just make sure it works, which I don't think it will because I have not yet actually put it in the level. So here we go. I'm going to replace one of these central palette tiles with the ghost spawn tile. Now let's try it. So there it is. It looks like it worked. We have a ghost tile now that appears here, and it's got one ghost already spawned in. As I add more ghosts, they're just going to all be there at the very beginning. In one of the future extensions, if you get that far, you can spawn in ghosts after a delay, only start with one, and then ramp up the difficulty. Hopefully I'll have time to demo that later. Okay, so now that we have that spawning, we need to actually write a script for the ghost. If we go into my start tile and my player's got the player script. In my ghost tile, Blinky does not yet have a script. Here's where we start getting into some decisions in terms of writing code for the ghosts. And if you're one of my students and you have the lab worksheet, or you'll have this written down. But if you don't have it on hand, or you're not one of the students in my class with that lab worksheet, a reminder of how the ghosts move. So ghosts have a goal. In addition to the target being the tile they're currently moving towards, they also have a goal. And that goal is where they're trying to get to. Each time the ghost reaches its target location, it gets to the tile it's been going towards, it needs to pick a new tile, similar to the way our player does. So here in our player script, we're checking for key presses to decide if we want to go up or right or down or left. The ghost is going to check each one of those and say, of all the tiles I could possibly move to, which one is closest in a straight line to my ultimate goal? I mention this because it gives us an idea of how we want to structure the inheritance for our ghosts. Our player script inherits from character. Our ghosts are also going to inherit from character. But all of the ghosts work a little different. I could just at this point make a Blinky script and a Pinky script, which are the two I'm making. But I'm going to put an intermediate ghost level because, as I mentioned, all of the ghosts have that same behavior of trying to get towards their ultimate goal. So I'm going to go ahead and create a new script for a ghost. So here's my ghost script. We don't want it to inherit from mono behavior, similar to player. We want it to inherit from character. Doesn't need a start method. You can see that update is underlined here and it's complaining at us. If you recall from the past lecture, we've made our method on character virtual, which means that it's okay for it to be overridden in a child class. So in Ghost, I just need to make this override, just explicitly state that, like, yes, I'm overriding the parent method. It's then going to yell at me again here because in character, update is public. So I can't in a child make it more restricted than public. So I need to make that public also. This should look familiar. If we go over to player, it's doing the same thing. Public override void update. I'm going to do one other new thing with inheritance, which is that because I'm going to create a ghost script, and then under ghost script, I'm going to create a different script for each ghost that inherits from it, which means I'm never going to apply the ghost script directly to any of the ghosts. So I'm going to make this an abstract class. Abstract is a keyword that effectively means this class will implement some code. It might define some methods but not implement them. But regardless, it'll never be created directly. The only way to create a ghost class is to actually create one of the children classes that inherit from it. We'll get to that in a minute, and it'll probably make a little bit more sense once you see that in action. But the important part to know is that this means I can make methods that don't have code for them because I'm never going to create the ghost directly. I can also make abstract methods, and it's something we're going to want to do here, which is that there are two things that a ghost needs to do. It needs to pick a new goal, and it needs to pick a new target. The way it picks the target is the same no matter which ghost it is. It's always the target closest to its goal. The way they pick their goal will differ between ghosts. And this is where abstract comes in handy for us. So I can let's make an update target method. So this is the one that's going to be the same for all of our ghosts. And I can write the code in here to update our target. But then we have another one to update the goal. I don't want to write code for update goal here because it's going to be different. So I'm going to make this abstract and just put a semicolon instead of creating the braces. This is what you can do with abstract classes. I made one method that I am going to write code for, and then I made another one that's abstract, which means anytime I inherit from Ghost, I have to implement this method or it won't be valid. Which also means that in Ghost, I can always rely on this to have been implemented. The important part of that being I can actually call either one. So similar to what we did in player, let's go back over here again. We're going to want to call these when we reach our current target. So let's start it the same way. Or I guess first let's have to call the base update method. So this will call the update method from the parent character class because we want it to move. After that, we want to check if we have reached our current target. So are we already at the tile that we were currently moving towards? Which is if our transform, let's try that again. If we have reached our current target. That was a case of Vim shortcuts gone wrong. So if our current position is equal to our target transform position. And I can do this because we inherit from character. Character has a target, target has a position. There are two things we need to do. First, we need to update the goal for this ghost. So actually, let's make an instance variable to hold that. So the ghost will have a goal, which is a vector 3. It's a three-dimensional position in space. That's where it's ultimately trying to get to. And that goal is going to be updated in this update goal method. So we need to update our goal if we've reached our target, see if we need to pick a new ultimate goal that we're aiming for. Because, for example, our first case is going to be picking whatever the player's current position is. So when I get to an intersection, I check where's Pac-Man. Pac-Man is my goal. So I call update goal. I haven't implemented it yet. I'll do that in the child class, which is, it's a concept called polymorphism. It's one of the key tenets, key principles of object-oriented programming. The important part is that this update goal will do a different thing depending on which child class it is, because they're each going to have their own code for this method. But I can call it because Ghost knows that it has that method. After we've updated our goal, then we can update our target based on that goal. Easy enough. That should be all we need in this update method, which is if we're at our current target, if we've reached an intersection, we update the goal we're aiming for, and then we pick a new target to move towards. So let's do the target first. At any given time, there are at most 4 potential candidates, or I guess there are always 4 potential candidates. We'll just eliminate some of them pretty quickly. And we can just make a list. So let's get a list of, or more accurately, I guess it's an array, not a list. An array of all possible target tiles. I'll just name it possible targets to be clear. And therefore it could possibly be, it could be the one above our current target. Or down or left or right. So here's, we're going to have to check all 4 of these to see which one is a valid tile to move to and closest to our goal. Let's create a variable to hold the current new target. So each time we check one, we'll see, is this closer? Am I allowed to move to this one? And is it closer than the previous closest option I found? So I'm just going to create a variable right now. So this is a variable to hold the new target. And at the start, I'm going to make this null, so we have not yet found one that's our new target. Now, we've got 2 cases here, at least at the beginning. So the first is, if this is still null, then any tile that's a valid tile to move to is going to be the closest one. It doesn't matter how far away it is because I haven't found any yet that I'm allowed to move to. So if it's null, I guess thing I forgot to do is first iterate through. So we need to make a loop for each tile in possible targets. Okay, here's where this goes. Got a little ahead of myself there. So for each tile, if the new target is still null, and this tile is an open, is an open tile, and it's not the tile we just came from. So recall with the ghost can't change directions. Unlike Pac-Man, you can't turn around. When you get to an intersection, or even if it's a straight hallway, you can't reverse directions when you reach your target. So If we haven't found a target, but this tile is open, and it's not the one we just came from, easy enough. That target is our new target is that tile. Otherwise, so otherwise, the case we want to check here is we have already found a valid new target, but now we need to check if this one's closer to our goal than that one was. So if it's not the previous again, and it's open, so slight difference in case here, in that now we're only checking. We're no longer checking. We know our new target's not null, but this tile is still not our previous one and open, so we do need to check it. So let's see how far away what we currently have saved as our new tile is. So that'll be the current minimum. And it's as easy as vector3 dot distance. Okay, so what I'm doing here is I'm saying currently the minimum, so we have one new target picked, and our current minimum distance is that tile's distance to our goal, which I'm using the vector3.distance method to say our goal, which is this vector3 that should have been set when we called update goal. How far away is that from what we currently have saved as our new target? So now let's check. Yeah, sure, that works. So now we want to check the distance between this new tile. I'll just put them in the same order. There we go. Okay, so get how far away this other tile is from our target. And now we just want to say, if this tile if the new tile we're looking at is closer to our goal than what we currently have saved, then we want to make it the new target instead. So if the new distance is less than the current minimum, new target equals tile. Okay, so that was a lot of code writing in a row, but basically what's happening here is anytime we want to update our target, we get all the possible targets, which is everything adjacent to where we are right now. We iterate through each of those and we say, if we haven't found a new target yet, this is a tile I'm allowed to move to, just make it the new target. Otherwise, we already found one that was a valid tile, but this one's also a valid tile, so we need to see which one's closer. Check how far away the current new target is, and check how far away the tile we're now looking at is. If this tile is closer than our current minimum, it should actually be the new target. And at the very end of all of this, the result should be that we set our target to the new target. And set target here is in our character script. We have a method called set target, if you remember this. So I'm calling that. Back over to Ghost. So at the end of all of this, this new target has been populated with whatever the closest valid tile is for me to move to. I'm going to make that my new target. And that should be everything we need to write for the Ghost class. The one thing that's missing here is that we can't apply this script because it's abstract and we haven't implemented our update goal. Here we go. So we need to add one more script, and this will be, or one more script per ghost that we're going to add controls for. And I'm going to make a folder just to make this a little cleaner. This will be the ghosts folder. And inside of that, I'm going to start out by writing a script for Blinky. And this is the script I'm going to directly apply onto the ghost I created on that tile. So coming back up into here, I now have this Blinky script. I don't want it to inherit from that. I want it to inherit from ghost. And I am actually going to leave. So you can see this is underlined in red. The reason is because, and if I hover over this, it'll say Blinky does not implement the inherited abstract member ghost.update goal. So that's perfect. That's what we wanted to see. In ghost, abstract update goal, Blinky is going to refuse to compile until I've written code for that. So let's go ahead and do that. We have void update goal. It's going to complain that I haven't given it the same access. It hides inherited member, so I need to override it. And then it's going to complain again because in ghost, as before, I made it public. I'm actually going to change that. I don't want it to be public. I want it to be protected. And this one can be private. In general, you want to make the access level as restricted as possible. So no one needs to call update target except the ghost script. No one needs to call update goal except the ghost script and maybe its child scripts. So I'm going to make them protected. And do the same here so that it doesn't get mad at me. And assuming I've done this right, which I have, so it's a protected, override, void, update goal. We're really starting to tack on the keywords here, but only accessible in this and children classes. Overrides the parents, which is the abstract version. It doesn't return anything. This is the update goal method. We're not going to need to call update. We might actually need start, so I'm going to do this. We are overriding the start method. It's unhappy with me. Override void start. That should be coming from the character class, which is public virtual void. Down in Blinky, this should now be happy, I hope. There we go. Okay, so what I did there is in the character class, I came up and I made start public and virtual so that I could see it from the Blinky class and so that I know I can override it. And the reason I did that is because Blinky is going to base its goal on where the player currently is. So at the very beginning, I'm just going to get the player and I'm going to keep track of where they are so that I can update my goal. So at the start, always a good idea to call the base start method, just in case there's any code in there that I need to call. And I need to set the player, and I'm just going to do a GameObject.find. The model's name is player. Or the game object's name is player. I might also, just because I want it to be easier to see when they're chasing, I'm going to make them a little slower than Pac-Man. So in character, we have a speed. It's currently a speed of 3. I'm going to make a new method. I'm going to make a set speed method that takes a float of the new speed. And speed equals new speed. Just to be explicit, this dot speed equals new speed. I could actually, this is a good thing to demonstrate, I can name these the same thing, which is why I put that this. So speed here refers to this one that was passed in, but this dot speed refers to the instance variable, this dot speed. Common thing you'll see, just recall that if you don't put the this, it's going to refer to that variable, so you can get yourself into a little trouble. Okay, back over in Blinky, I have found my player object. I'm going to set my speed to 2. I'm going to write myself a note just so I remember I did this. write myself a note saying that I set the speed slower just so that I can see what's happening in case I'm wondering why I did that later. And now this is actually pretty easy. In our update goal, we know that in Ghost, we have this goal. To make this easy, I'm actually going to come up here and I'm just going to make this protected. So protected means that now in the Blinky class, I'll be able to access this variable. So I can say goal equals player.transform.position. And that's all you need for the Blinky script at this point. We did all the heavy lifting in the Ghost script, and each of the ghosts will just need to implement this in a slightly different way. So all I'm doing is saying when update goal is called, which happens here, it updates our goal, then it updates our target. So when this gets called, if this ghost is Blinky, Blinky will set its goal to be the current position of the player. Let's just see if that works and find out what I did wrong. Okay, we have our prefab, which is where Blinky exists. So there's Blinky, and we need to give Blinky the Blinky script. So here we go. It's got a target and a previous that it's inherited from character. Let's go ahead and assign those. Similar to how we did before, those are actually just going to be this tile it spawns on. And now if all goes well, what should happen is that when I run the game, Blinky's going to start moving. It's going to pick whatever's the closest tile towards Pac-Man. When it gets to that one, it's going to check the next one that's closest to Pac-Man. Fingers crossed. So there we go. It's moving. It looks like it is moving towards me. And that all looks pretty good. Blinky is now chasing our Pac-Man around. Made it slower, so it's very easy to avoid, but that all works as expected. So we got one ghost. Awesome. Now we need to make a second one. As I mentioned earlier, just to make this easy, I'm just going to stick it directly onto this same tile prefab, and I'm not going to worry about spawning it in. So I'm going to Control D, duplicate Blinky. This one is going to be Pinky, is going to be our second one. Pinky should not have the Blinky script though. So we want to make a new script for Pinky. So the way Pinky works is that instead of aiming for Pac-Man directly, it's going to aim a little bit ahead of Pac-Man. It's going to try to cut it off. So this way you'll have Blinky aiming for it and Pinky trying to get out ahead. How do we do that? Let's get so we can see both of our scripts at the same time here. So here's Blinky. Now we're going to open Pinky on the left. And in fact, let's start out very similar. We're aiming ahead of the player, so we do probably want to know where they are. So let's do this exact same thing. Make a variable to hold the player. And at the start, we're going to override the start method. And inside of that, we're going to call the start method from the parent. Which it's yelling at me because I have not yet made it inherit from Ghost, so it couldn't do that. Now it's happy. Other than the fact that it's complaining that I haven't implemented update goal yet. We can get rid of the update method. So there's the base.start. Same thing as we have on the right over here, GameObject.find. Let's find the player object. I'm going to do the same thing again where I'm going to set my speed to be a little bit slower so it's clear. And that'll also be nice because then we'll be able to see that they behave differently because they'll be going the same speed. At some point, they should branch off in different directions because they'll pick different targets. Okay. In this case, we want to again override the update goal method. And here, what we want to do is we want to aim not directly for the player, but a little bit ahead of where they're going. How do we do that? So first thing we need to do is we're actually going to need to figure out what their target is because we need to figure out what direction they're currently moving in. So I need to get the character script off of Pac-Man. Important thing about inheritance. Notice here, I'm actually getting the player component, but I'm assigning it to a character type. You can do that. I can save a player as a character. I could also save, I could save this as a character because Ghost is technically, or this is Pinky. Pinky is a ghost. Ghost is a character, so I can save this as a character instead of as a Pinky. Because the only thing I need access to is I want to know what its target is, and its target is on the character script. So I don't care about all the code in the child classes. As long as it's got the character's target, which I know a player has. So I can now use this to get the direction they're traveling. The way I'm going to do this is I'm just going to get the vector between the tile the character left to the one that they're going towards. This will be their direction vector. Oops. So this is Pac-Man. Not Pac-Man. Pac-Man, which is this character here. So the position of its target minus previous transform. Okay, so the vector from the tile it just came from to the tile it's going towards. That's the direction. And then my goal let's say plus 3 meters. So I want to make my goal in this case, I'm going to say that it's going to be wherever Pac-Man is plus 3 meters in whatever direction it's currently traveling. So like before, here it was simple. We were just setting it to the player's position, but this time I can still set the goal to the player's position plus 3 meters times, and let's just normalize it. Okay, so this is the player's position plus take the direction vector, make it a length of 1, multiply it by 3. So this whole thing here is going to be 3 meters in the direction it's traveling, stick that onto Pac-Man's current position. That's what my new goal is. Slightly more involved, but at the same time, it was only 3 lines of code. I've got 3 lines of code difference between the Blinky and the Pinky scripts, but they should now behave totally differently. So here's Pinky. We should probably make it visually distinct, not a prefab. Let's give you a new material. This is the Pinky material. I should probably call it Pinky Matte or something just to make it clear, but for now, I'm just going to do this. It's an unlit color. Pinky is pink. I want to make sure I'm actually applying it to the right thing, so I'm going to briefly just move you up a little. There's Pinky. Pinky is pink. You can go back now. Oops, except I moved the wrong. This should be at 0. It should be on the cube, which is 1. Yep. Okay, so they're right on top of each other, but they'll both be there when the game spawns. And then I need to make sure that my Pinky does actually have the Pinky script on it. So there it is. Its target at the beginning is this tile. Now if I go back to my scene, fingers crossed. So they should both be overlapping right now, but at some point in theory, if I can get them, there we go. So they split off. So Pinky picked a different tile because it's not aiming for where I currently am, it's aiming for where I'm going. At some point, and I didn't trap myself because they picked the right direction. If I can get them back overlapping, you can see they're both chasing me down, but they're not doing it quite the same way. And that's kind of the core idea behind Pac-Man. You have 4 ghosts, but they're never going to just follow directly behind you. They're all picking in different ways. If I stay here for long enough, they'll both catch me. So there's one. That one actually, it's funny, it won't, because its closest tile in a straight line, because it picks in a straight line, is always going to be up instead of right. So Blinky will never catch me. Now let's try that one more time just to show. They start out moving the same direction because their initial target is straight at me. And then they split off because one tries to get out ahead and one goes to where I currently am. And it's as simple as that. If you wanted to now make 2 more ghosts, all you will need to do is come in here and create scripts for Inky. I say as simple as that. It's a lot that we just did. The next steps will be as simple as doing that again, is what I mean. I don't mean to minimize the challenge there. There we go. So now we have scripts for Blinky, Inky, Pinky, and Clyde. I'm not going to implement them. I'll leave that to you to get creative with. But if we come over here and make Inky a ghost, which means it needs to implement update goal. And Clyde is also a ghost. That implements not update. That. There we go. If you wanted to implement the 2 other ghosts, you just make 2 more models, and in each of them, you write the code inside of here to set the target. And that's it for this portion of the lab. It's a longer one. This is why we gave you some extra time on this lab. Writing the ghost is a little bit challenging, but once you get the basics of the ghost script, and let's look at that one more time. Really, the important part of this is in this ghost script, the fact that we can, when we reach our target, update our goal and let the child script decide what that goal is, and then update our target, which all ghosts do the same. It should all work. So that covers it for this portion of the lab. The next sections are on loading a new level, like creating a new scene, loading a new scene with a new level on it when you win or whatever case may happen. And then also keeping track of a high score, a running high score, even after the game is paused. So, best of luck.